Yes, it all started with a big bang. And as the cosmic dust was settling down to form galaxies, stars, and planets, there was one element that was busy creating life. And after millions of years of evolution, here we are on the Capitol Hill celebrating the 150th year of the invention of the periodic table. And that life-giving element, my dear friends, is carbon. Although the human body is made up of several elements, carbon is the key. Carbon is the only element in the entire periodic table that can form long, complex chains called molecules. It is these molecules that form the backbone of the DNA, and that is what makes life possible. Without carbon, there could be no life. A large portion of food that we consume is carbohydrates, and all our plastics and polymers like water bottles, tables, chairs, pens are all made up of long carbon molecules. Carbon exists on the surface of Earth as coal, diamond, and graphite. Graphite, although looks like a lump, is actually made up of several millions of sheets of carbon stacked one on top of other, like a deck of cards. In 2004, two British scientists were able to isolate one sheet, just one sheet of carbon using a Humple Scotch tape, right? And when the properties of this one sheet of carbon were measured, it was like it was straight out of science fiction. That one sheet of carbon, now called graphene, is 200 times stronger than steel. You would need a fully grown adult elephant balanced on the tip of a pen to puncture through one sheet of graphene. That's strong it is. Now, we at Argonne use this wonder material to solve a major engineering challenge, and that is friction. There are about 250 million vehicles on the roads of the United States today, and every day we use 2 million barrels of oil to overcome friction. And that is just from automotives. There are several other mechanical systems, and if we could eliminate just 1.3% of friction from all mechanical systems, we could be saving $12 billion annually. That's a big number. In 2013, Argonne scientists made a breakthrough discovery. They engineered graphene, the one-sheet layer material, they engineered graphene to be used as a solid lubricant. It's an oil-free solid lubricant for the first time in the world. And when this engineered graphene is introduced into rolling or sliding mechanical parts, they form tiny ball bearings. Tiny ball bearings, they roll. And this was observed to bring down friction to near zero, right? So this phenomena is called vanishing friction or superlubricity. In my project, I work closely with world's largest automotive manufacturer out of Detroit to commercialize this technology. And how do we do it? You see, the chassis of a car is actually made up of long sheets of steel bent into complex shapes using robotic arms. And when this robotic arm is actually bending the sheet metal, there is immense friction where the actually robotic arm touches the sheet metal. And this immense friction can produce tiny cracks or soft spots that could be catastrophic in the case of a collision. Now, engineers mitigate this problem by making the sheet metal thicker. That is why we have cars and driving and we are safe. Now, we have shown that by using graphene at the interface where the tool and the sheet meet, it lowers friction by about 70%. So we are not only making passenger cars safer by eliminating friction and by eliminating cracks, we can also contribute towards removing the excess material that is put in as a factor of safety. This directly contributes to automotive lightweighting. This is good for the industry because, if our calculations are right, we will be saving about $450 million per manufacturing line per year. This also helps us accelerate towards developing more efficient electric vehicles. This technology is great because it is good for the environment, it is good for the economy, and most importantly, it is good for the energy security. In a couple of years from now, when you see the next generation high-efficiency fuel vehicle, remember that carbon is the slick element. Thank you.